All right, come back to this. So let's import class image. Just choose yes here. Import image classes, and this is the image with classes. If we're here, we can just view it. First select the first image. We can see it here that this is the biggest part of the this is the biggest part with artifacts. Here we've got the deformation, we've got some artifacts here as well. Then if we check the classes, so this is the class -1, which is the artifacts. Here we can see it the artifacts as well, and on the bottom, then the actual deformation, class 6, which is -2 to 20 millimeters. Then from 20 to 10, from 10 to 5, from 5 to 0, and no deformations here. No deformations here. What we can do with this image, what we need to do with this image to get to the model, we need to reshape this image like the parameters that need to be one matrices. This is done by this process, reshaping, and we can see it. We can see it here that the image is just one big matrices with this 1 pixel by 1 pixel. Then we can set here. We need to set a few settings before we start. So our model is the learning model. So we have to set out this as a training data set. The current model is 1, and we need to apply to this model the Y data, which are the testing, which are the classes. This set is actually the second set. If we check it, we've got master learning type, activate. The set for X data, it's in set 1. If we check it here, this is the number of the set. So the second set is for testing data. If we go here, the classes data. So the classes data with set 2. Also, before we running the machine learning. Machine learning requires that data needs to be standardized. By standardized, I mean standardization bar by comparing this to the standard deviation, removing actually the standard deviation from the data. This can be done here. Standardization, it's very fast process. The next one, the classes. If we have just 2 classes, they can work with this, which are which can be done just classes like artifacts and non-artifacts. However, here in this process we are using a few classes. One of them is artifacts, non-artifacts, the second one, and few classes with deformation range. So we've got actually 7 classes. To apply that to the model, we need to reshape these matrices to that each class will be comparing to the others as a 0 and 1. So it can be done here, 1 versus rest. If we go and check it, we've got 1 versus rest data with 6 classes. Sorry, it was 6, not 7. This is the number of the pixels which we have in the model. So we've got 20,000 pixels to learn. And so let's go with the learning process. It's taking a moment to learn, so we can actually check it how it works. Here I've got a small picture with the processing structure. Here we've got the original image. As before said, we are stacking the image by matrices. Each of this small square, it's matrix mask for each pixel. The number of the pixels is just n square. Then from that we are going to parameters. It depends from the number of parameters, the number of columns here, but the number of pixels here it will be also n square. From that we are learn the process and we'll get the weights. It's actually learning process is done. Here we've got for each classes the sum of the logistic cost. This is the, let's go to full screen. So it's learned in 50 iterations by default. We can change it. The number of classes is 6. So we can see it here on each iteration how the cost it's going down, and it's actually after around 50 iterations it's almost not changing. And what it means, it's actually the cost, it's the actual error for this class and the rest one. So it's actually learning on each classes one by one. If we'll check how it looked like in the image, so we can go with probabilistic image. Because of the logistic regression, it works like this. So this is the function which this model is using. This is sigmoid function. So if the parameters with weights are higher than 0.5, then the class applied for this pixel is 1, and if the function result is lower than 0.5, then the class for this pixel it's 0. And with 1 versus rest system, the 0 is applied for the rest of the classes, and the 1 is applied for the particular class. However, from this function we can also get what is the probability of this class applied for the pixel. So for example, if we check it here, we can create a probabilistic images for each classes. Let's do it now. Let's view it. Okay, so for each class we actually have probabilistic images. Here the range is from 0 to 1, and we can see it here clearly that almost all this area, it's almost with 100% sure that this is the artifacts here as well. However, here it's almost 100% sure that there is no any artifacts here. The next class, let's check it. The sixth class, which is the lower deformations, and as we saw on the image with values, we saw that the lowest deformation are here. Then the next part is this one. As we can see from one part to another, we can see that the probability is going down, but not like the cutting edge. It's going linearity, but we can predict actually what is the class for each image now from the model. So this is the predicted image. To compare it with the actual class image, let's save it. Let's, for example, here type it predict image. Let's go and check it. Select the first one, view it. So the second one. View it. So this is the actual classes, and this is the predicted one. We can see it here. It's more or less the same places. There cannot be like with the small variations, it's very hard to detect which are actually the class. However, it's predict very good the area where we have the artifacts and where we have the actual deformations. Depending from the range, this one it can be smaller because of the values around that. It's very close to the edge of the range. So that's why it's actually this class. It's the prediction is applied for the class 5 and not to the class 6. However, more or less the prediction it works. This is the very small learning data, which is just 20,000 pixels. When we will work on further with the more images, the model it will works much better. But let's check it how it works with the real big images.